Okay, algebra students, the tutorial carries on, and we are now going to look at a couple of problems that have to do with a concept called the difference of two squares. Now let's take a look at the problem. This is number 21, number 22, number 23, and it looks like number 24, all from Builder 18. These have to do with the difference of squares. So let's take a look at number 21. Okay, so here's number 21. What we're given is x squared minus 25. Okay? Just kind of think about this here for a second. I need to factor this, but it doesn't look like a standard quadratic function. Here, let me divide this page in half, kind of like I did that other one. And we'll kind of have half of the page be the problem, and then this other half over here, this will be notes and side work. Okay? So let's consider this for a minute. Let's look at x squared minus 25. What does it appear to be missing? Like, this is what I'm trying to get you to think of. What is the standard form of a quadratic function? Okay, here's the standard form of a quadratic function. This is called standard form. Standard form is ax squared plus bx plus c. So with our given example, we have 1x squared, so we have ax squared, and then we have c, which in this case is negative 25, but there doesn't appear to be any bx term. Well, as a matter of fact, there is. We can actually rewrite this. It's just 0x. Okay, we can rewrite this as x squared plus 0x minus 25. So the question becomes, what two numbers can be added together to equal 0 and multiplied together to equal negative 25? What two numbers can be added together to equal 0 and multiplied together to equal negative 25? Well, if you don't know, you could take negative 25 and factor it. Okay, let me move this over a little bit. So here are the factors of negative 25. We have negative 5 and 5. Now, negative 5 times 5 equals negative 25, and negative 5 plus 5 equals 0. So your factors are negative 5 and 5. Negative 5 plus 5 is 0. Negative 5 and 5. Okay, so this means that our factors, so if I'm going to say factor x squared minus 25, okay, I could write those factors as x minus 5 times x plus 5. Okay, because what I'm doing is I'm getting that minus 5 factor here and that plus 5 factor, here. Remember, these factors are like potential solutions. You have x plus 5 and you have x minus 5. Okay. Now set these both equal to 0 if you want to see what's really going on here. And now add 5 to both sides here, and you have x equals 5. And over here, you subtract 5 from both sides, and you have x equals negative 5. These are the x-intercepts. X-intercepts. If I were to sketch a graph of this quadratic function, okay, I would have to draw it like this. Way down here would be minus 25, and this would be the y-axis, and this would be the x-axis. And I would have negative 5 and 5, okay, written out. And then my graph would look something like this. Would look something like this. I'm using a highlighter here because this is obviously a sketch, right? It's a sketch. It's not intended to be a, a perfect rendition of the function. Okay, so the y-intercept of the function is negative 25. Okay, but see the zeros are negative 5 and positive 5. So when you're factoring, you're getting the factors that could be multiplied together to get the original expression, and those factors can easily be turned into zeros or the x-intercepts of the graph. Okay, so those x-intercepts are negative 5 comma 0. Okay, notice when x is negative 5 and 5, y is 0. So the two x-intercepts are negative 5 comma 0 and 5 comma 0. All right, so we're still over here. We're still kind of getting to the problem, right? But this is the backstory. This is what's going on. I want to show you a different way to solve it, though. I think this is a cooler way to solve it. It's kind of like a way of thinking about it. So on here and focus on the term difference of squares. And specifically on the squares part. What does it mean and why am I highlighting it? Why do I feel like this is an important word? Okay. Well, take a look at x squared and negative 25. So here's where the difference part comes in. It's a difference, okay, that means subtract, of squares. So take a look at this. So we have x squared minus 25. Now let's play with this thing for a second. Set this guy equal to 0. All right, now watch what happens when I move the 25 to the other side. Okay, have I broken any laws? No. So now I have x squared equals 25. Well, what would x be if x squared is 25? Well, before we start taking square roots, because some of you are saying take the square root. Let's just take a look at this here. What is x squared if not x times x? And what is 25 if not 5 times 5? So there's your squares. 25 is 5 squared, right? Now, let's go back. Let's bring this guy around back over here and write it again. X squared equals 25. So what I'm going to do is take the square root of both sides of this equation. The square root of x squared is x. Okay. Ponder that. The square root of x squared is x. Let me explain why that is. All right. Imagine, let's go over here. Imagine you have a square. Okay. We'll make it look like a square-ish thing. You have a square, and the area is x squared. What are the side lengths? Side length s, side length s. Well, the side lengths are going to be x and x because x times x, use your exponent rules, equals x to the 1 plus 1, or x squared. Now, this is not necessary for the problem. I'm trying to help you integrate some of the things that we've been talking about. Okay? So that's why the square root of x squared is x. Now go back over here. How about the square root of 25? Well, the square root of 25, we're taking the square root of a number. To take the square root of a number, you have to say plus or minus 5. Okay, and that's because when we prime factored 25, we got 5 and 5. You say, well, why plus or minus 5? Why do they always make us put plus or minus 5? Well, here's why. Because we don't know. 5 times 5 equals 25. But negative 5 times negative 5 also equals 25. So if I take the square root of 25, I really don't know if it's going to be plus or minus. So I have to put plus or minus 5. Now this can be turned back into the factors by, you could create two equations. You have x plus 5 and x minus 5. How did I get that? Well, because x equals positive 5 and x equals negative 5. So if I want to get my factors back, I can subtract 5 from both sides here. Now I have x minus 5 equals 0. There's a factor. Over here I've got put plus 5, plus 5. Now over here I've got x plus 5 equals 0. That's a factor. So this is how we're coming up with the factors. These are both called factors. These are factors. Okay? When you get them set equal, you say, well, plus 5 out. Now I've got x equals 5 and x equals minus 5. These are solutions or zeros. So solutions and zeros both refer to the x-intercepts if they are real. It's a little bit different if they are imaginary. Okay, well, we're going to keep rolling a little bit faster through the next couple of problems. So to make very, very clear, I don't want to leave anybody wondering, well, okay, now with all that mess that this guy just wrote, I have no idea what the answer to the question is. All right. The factors of x squared minus 25 are x plus 5 and x minus 5. There's your solution. These are the factors. Okay, now let's look at another one. Let's look at x squared minus 49. So this is number 22. Number 22. X squared minus 49. Okay, factor this. Well, it says it's the difference of two squares. Well, what squares are those? Well, it's the difference of x times x and 7 times 7, right? Because 49 is 7 times 7. 49 is 7 times 7, or, it's important, negative 7 times negative 7. And x squared is x times x. Okay, so let's go back over here and take a look at this. Remember that we could rewrite, as x squared plus 0x minus 49. Now this will appeal to some people, or to some others it might not appeal to them. And then you can use your kind of the more familiar trick. Okay, the numbers need to add to 0 and multiply to be negative 49. Okay, well, I need two numbers that add to 0 and multiply to negative 49. How about negative 7 and positive 7? Yeah, those two numbers add to 0 and multiply to 49. So my factors would be x minus 7 and x plus 7. So those of you who are merely interested in the answer, okay, here's where I'm getting that. take my minus 7 there, and my plus 7 goes here. Okay? So those are the factors. You know, if you ever want to check this, you can always use FOIL to check. Use FOIL to check. First, outer, inner, last. Let's do that together. First, x times x. And that's x times x. Outer, 7 times x. So I got plus 7 times x. Inner, plus negative 7 times x. Last, plus negative 7 times 7. All right, this is FOIL. First, outer, inner, last. FOIL. F-O-I-L. It's just a little trick, you know. You could also use the box. X times x is x squared. 7 times x is 7x. Negative 7 times x is negative 7x. And negative 7 times 7 is negative 49. Now look what happens in the middle. In the middle I have positive 7x minus minus 7x. So I've got positive 7x and negative 7x. These are going to cancel each other out. Okay, so take these terms here in the middle. These cancel out. And all that you're left with at the end is x squared minus 49, which confirms back to the same. You know you did it right. So that's how we know that x minus 7 times x plus 7 is indeed the correct answer. Okay? Pretty easy. Okay, now I would like to look at two problems where there's a leading coefficient, but it's still a difference of squares. Okay, same idea. And this is going to be number 23 from the builder. Number 23. And here's what we're given. 16x squared minus 49. Factor this. Okay. Now remember, let's get our side work over here. We could have rewritten this as 16x squared plus 0x minus 49. Okay, and if you wanted to, you could multiply 16 and 49 together, and you could work it out like that, 16 and negative 49. And that that may be what you choose to do. But I want to just kind of dig into this a second. Remember, we're still working with this concept called difference of squares. It shouldn't be too complicated, and it should have something to do with squares and their roots, not multiplying 16 times negative 49. That just seems way off base to me that we should be doing that. So let's leave that and let's try something else. Try something else. Okay, let's take our expression again. 16x squared minus 49. Okay, let's notice a couple of things. Notice everything is a square. 16 equals 4 squared. Well, you could say plus or minus 4 squared. X squared equals x times x, and negative 49 equals negative 7 times 7, which equals negative, open parentheses, 7 squared. So they're all squares, right? Well, let's try this. Try setting this equal to 0 and moving the 49 to the other side. What's left on the left side of the equation is 16x squared, and that equals positive 49. Well, I want to get x by itself, so I'll divide both sides by 16. Canceling the 16 out on the left, and on the left I have now x squared equals 49 over 16. Resist the temptation to actually compute this. I want us to think about this for just a minute before we take the square root. Think about this. This equals 49 is 7 times 7 over 16 is 4 times 4. Okay? So, just so, right? So let's take it easy. Let's take this slow. X squared equals 7 times 7 divided by 4 times 4. I've just rewritten 49 as 7 and 7, and 16 as 4 and 4. Okay, so now I'm going to take the square root. Let's take the square root. And remember the rule of square roots. If I'm taking the square root of a rational expression means like a fraction. I'm taking the square root of a fraction. I can rewrite that as the square root of the numerator, I should say plus or minus, the square root of the numerator, 7 times 7, divided by the square root of the denominator, 4 times 4. So here is something to think about. Okay, square root of x is just x. So now x equals plus or minus, and now stop and think. What is the square root of 7 times 7? Well, this is 7 squared, right? Maybe let me just write this. I want to make this super clear to you guys. This equals plus or minus the square root of 7 squared divided by the square root of 4 squared. So what is the square root of 7 squared? Well, it is just 7 over the square root of 4 squared. What is that? Well, that's just 4. All right, so here's what I'm left with. I have 2 solutions. You're always going to get 2 solutions. I have x equals 7 and 7 over 4. Pardon me on that. And x equals negative 7 over 4. So if those are my solutions, my factors are just me setting these things equal to 0. Set each equal to 0. Okay, so I'm going to subtract 7/4 from both sides here. So I have x minus 7/4 equals 0, and x plus 7/4 equals 0. All right, now these are my factors. So these are factors. X minus 7/4, x plus 7/4. But we need to do something to these two things. So let's bring them up here. Let me bring these guys back up here. So we're going to say the factors are x minus 7/4 and x plus 7/4. Here's the thing. This is something to keep in mind. Factorization, they don't like having fractions. So I need to get this fraction out of here. What can I do to get this fraction out of here? How can I get rid of the fraction? Well, does anybody, I just want to leave the microphone kind of open here for just a second. Let me put it on pause for a second. Think about how you could rewrite this thing, rewrite each factor such that you didn't have a fraction in there. Okay? So, did you think of a way that you could get rid of the 4? Okay, let's try this. Let's try timesing out the 4 by multiplying, let me use a different color, multiplying the negative 7/4 by 4. What would that do for me? Well, that would indeed pull, it would get rid of the 4, it would cancel the 4. But what I would be doing is I would need this to become, so I would put the 4 here, and that would cancel the 4, but now I would have 4x minus 4 times, well, it would be canceled out. Yeah, so it would be 4x minus 7, and that's different. We can't change the underlying equation, so that doesn't work. Think about what else you could do. What else could you do? Okay, so this is the hard part of math, is to think what to do. All right, so now let's get back to, you've got x minus 7 over 4. What can you do? What can you do to get rid of the fraction? If you try to pull out the 1/4, you will have a problem, because if you pull out a 1/4, you will leave behind a 4 underneath the x. So that's not going to work. Again, I'm trying to make a point here by not just providing the solution as though it is magic. What can I do? Right? What if let's go back up here, okay? Back up here. What if I multiply this equation by 4? Can I do that? If I do that, I'll have 4x minus 7. That's something I can do. I don't think so. I don't know. Maybe I can, right? Maybe I can. Let's try this out. Let's try this out and see if this helps at all. Is there anything I can do to x plus 7 over 4 to get rid of the fraction? How do I get rid of the fraction? So here's the problem, guys. 4x minus 7 does not equal x minus 7 over 4. That doesn't work. All right, well, this is something in mathematics where you can do this and just see if something works, right? Because I'm sensing that the general consensus is, we have no idea, right? How do I get rid of the fraction? I can pull it out of the equation like this. 4. So now I have 4x plus 7. Down here I have 4x minus 7. So I've got 4x minus 7 times 4x plus 7. Does that equal 16x squared minus 49? Let's see. 4x times 4x equals 16x squared. 4x times 7 equals plus 28x. Negative 7 times 4x equals negative 28x. And negative 7 times 7 equals negative 49. So 16x squared plus 28x minus 28x minus 49. These terms cancel in the middle. These terms cancel in the middle. I've got now 16x squared minus 49. Okay? So let's revisit something. That works because that's exactly the same thing. So let's go back here. I got 4x minus 7, and we were looking at whether that equaled x minus 7 over 4. I think this is important. Does it equal? Well, we could try a number. You could say, well, what if x was 1? If x is 1, then you have 4 times 1 minus 7 equals 1 minus 7 over 4. Well, what is 1 in terms of 4? 1 is 4 over 4 minus 7 over 4. So I've got here negative 3 equals negative 3 over 4. And those do not equal one another. But still, this worked. Still, this worked. Total mystery to me. So we'll look at that later. Now I'll move on to number 24. Okay, this is number 24. Number 24 is 49x squared minus 16. 49x squared minus 16. So I want to factor this. All right, well, you know what? We could do all kinds of factoring tricks, or I could just set this thing equal to 0 and add 16 to both sides. Now I've got 49x squared equals positive 16. Divide both sides by 49, and I have x squared equals 16 over 49. And remember, that can be rewritten as 4 times 4 over 7 times 7, which can further be rewritten as 4 squared over 7 squared. So now x squared equals 4 squared over 7 squared. And what I want to do is take the square root of both sides. And when I take the square root of both sides, I get x on the left equals plus or minus the square root of, I'm going to split these up by numerator and denominator, 4 squared over the square root of 7 squared. Okay, now the square root of 4 squared is 4. So x equals plus or minus 4 over square root of 7 squared is 7. So now I've got this same problem I had before. I have two solutions. One of the solutions is x plus 4 over 7 equals 0, and x minus 4 over 7 equals 0. And I have, these are the factors. Again, we have that same problem we had before, is that I want to get rid of the fraction, but it seems like I'm breaking the laws of mathematics. So let's get rid of these parentheses and go back to this. X plus 4 over 7 equals 0. And let me get back to my solution. X, so I'm going to put minus 4 over 7, minus 4 over 7. Now I'm back to my solution. X equals negative 4 over 7. Now, what if I wanted to get rid of the 7? Well, I could multiply everything by 7. Okay, distribute the 7, and that would cancel down here. So I would have 7x equals negative 4. It's a perfectly legal thing to do. Okay, so now if I wanted factors, I could add 4 to both sides, and I would have 7x plus 4 equals 0. And this was the key right here, setting it equal to 0. Remember in that last problem, we were concerned because it seemed like we were pulling out that 4 and we weren't doing anything with it, right? It seemed like we were breaking the laws of mathematics. Well, remember, here we could have x equals 7 over 4. Multiply the whole thing times 4. Now you have 4x equals 7. So subtract 7 from both sides, and you have 4x minus 7 equals 0. And that is fine. So we didn't break